Hi, I'm Madhumita from first MSc Physics. Um, I'm going to take a PPT on topic Euler's theorem and Euler's angle. Um, Euler's theorem: a rigid body can have two independent motions of translational motion and rotational motion. The general displacement of rigid body with one point fixed is a rotational about same axis. According to above theorem, we can always obtain the body set axis at the means of single rotation of the initial set of axes, which may be coincident with the space set of axes at the initial time. The magnitude of a vector does not change, only its direction may undergo a change, and the magnitude of the vector remains unchanged. Let the rotation be brought about by a matrix A, and if some such a vector along the axis of rotation be r, then the transformed vector r dash must be identical with r. R dash is equal to AR is equal to R equation 1. This equation is of the form of AR is equal to lambda R into lambda is equal to 1. This equation is second equation called an eigen's value equation, where lambda is a constant. Now equation 2 can also be written as A1 a minus lambda 1 into r is equal to 0. This is a third equation. I is equal to identity unit matrix. Equation 3 constitutes a set of simultaneous homogeneous equation. Mm, Modulus a minus lambda I is equal to 0. It's a equation 4 written in full form. Matrix A11 minus lambda A12 A13 A21 A22 minus lambda A23 A31 A32 A33 minus lambda is equal to 0. This is a cubic equation in lambda. Its roots are lambda 1, lambda 2, lambda 3, which we denote by lambda x, where k is equal to 1, 2, 3, where corresponding eigenvector r1, r2, r3, etc. The set of equation for lambda is matrix A11 minus lambda A12 A13 A21 A22 minus lambda A23 A31 A32 A33 minus lambda matrix x11 x12 x13 is equal to 0. X11, X12, X13 are the three component of the first eigenvector R written for R2, X21, X22, X23, and for R3 with component X31, X32, X33. Ax is equal to X lambda, and this is a equation 5. X is equal to matrix X11, X12, X13, X21, X22, X23, X31, X32, X33. Modulus A minus lambda I is equal to 0. This equation is a 60 equation written in full form. Matrix mm, matrix Matrix A11 minus lambda A12 A13 A21 A22 minus lambda A23 A31 A32 A33 minus lambda is equal to 0. This is a cubic equation of lambda, and its roots are lambda 1, lambda 2, lambda 3, which are denoted by lambda k, where k is equal to 1, 2, 3. The corresponding eigenvector r1, r2, r3. The set of equation from lambda 1 is matrix A11 minus lambda 1 A12 A13 A21 A22 minus lambda 1 A23 A31 A32 A33 minus lambda 1. Matrix x11 x12 x13 is equal to 0. X11 x12 x13 are the three component of the first eigenvector R written for R2, x21 x22 x23, and for R3 with component x21 x22 x23. Ax is equal to x lambda. This is the equation 5. X is equal to matrix x11 x12 x13 x21 x22 x23 x31 x32 x33. Lambda is equal to matrix lambda 1 0 0 0 lambda 2 0 0 0 lambda 3. Multiply equation 5 number on the left by x minus 1 to obtain x power minus 1 ax is equal to lambda, and this is the equation 6. Eigenvalue lambda 1 lambda 2 lambda 3 of the matrix A. Similarity transformation. First one, it must and be orthogonal matrix, since an orthogonal matrix leaves the magnitude of any vector unchanged. A transverse is equal to a power minus 1. This is a seventh equation. Second one, as time progresses, the orientation of the body will change and the matrix of transformation will be a function of time. A is equal to a into t. Third one, further the matrix A into T must correspond to a proper rotation, i.e. its determination must to be equal to its. We also know that the determination of the transfer of A is equal to A will also be equal to T. Um, a minus 1 into A transverse is equal to 1 minus A transfer. Modulus A minus 1 into A transfer is equal to A minus I into modulus A transfer. 1 minus A transfer, um, modulus A minus I is equal to 1, modulus 1 minus A is equal to um, modulus minus A minus 1. This is a equation 9. A minus 1 is the same as the determinant of its negative, or is the order of the square matrix. Modulus A minus 3 is equal to modulus minus A minus 1 is equal to minus 1 power n modulus A minus 1. This is equation 10. In third determination dimension space, n is equal to 3, equation 10 can be satisfied. Modulus A minus I is equal to 0. This is equation 11. Lambda must be positive 1. Modulus A dash is equal to modulus x power minus 1 ax is equal to modulus lambda is equal to lambda 1 lambda 2 lambda 3. Lambda 1 lambda 2 is equal to 1. Euler's angle. Euler's angle. Let us proceed to final three independent parameter which would completely specify the orientation of rigid body. The so-called Euler's angle. Let x, y, z be the orthogonal space let of axis with I, j, k as unit vector along this axis. Also, x dash, y dash, z dash be the orthogonal body set of axes with I dash, j dash, and k dash. Unit vector along their axis xg plane is different from x dash minus y dash. Y minus 2 plane is different from y dash minus z dash plane. We rotate space set of x y z coincide with body set of axes x dash y dash z dash. Thank you.